Hello everyone, I'm Mr. Lau over here. I'm going to give an online tutorial today. So first of all, we're going to look at question number 1. Question number 1 is basically about the summation sign. So part 1, we are supposed to prove the relationship of un plus 1 minus un. So it is very simple. We just have to write down the expression of un plus 1 and subtract it by un. So we are going to combine this by finding a common denominator. Next, we can simplify the numerator by expanding the quadratic and we can clearly see that the n squared term can be cancelled off. By factorizing out minus 4, we are left with n plus 1 in the numerator, which can be cancelled off with one of those in the denominator. And this gives us the expression that we need. Next, for part 2, we are supposed to find the expression for the summation sign. Since the word hence is being used, we have to use the previous result. So we'll write down the previous result that we have proved in part 1. So in order to obtain what is needed, we are going to apply the summations operator to both sides with lower limit n equals to 1 and upper limit capital letter N. So the expression on the right is what we need. We're going to take out the minus 4 since the expression don't contain the minus 4. And this minus 4 shall be shifted to the other side. So now on my right hand side is clearly a matter of difference. So we are going to expand the summation sign. From this expansion, we can clearly see the common terms. Therefore, we shall cancel the common terms. And what's remaining is un plus 1 minus u1. So we are going to put in the expression for un plus 1 and u1 is given as a quarter. We are going to multiply the minus 1/4 inside to obtain the final expression. That's it for part 2. Next, for part 3, it is asked whether the series in part 2 is convergent. And if it is, state the sum of infinity. So for this, we're going to consider the limit of n approaching infinity for the expression in part 2. We'll replace the summation sign with the proven result. The limit of n to infinity simply requires us to sub n as infinity into the expression. And this will make the second term 0, since 1 over infinity is 0. So I'm only left with 1 over 16, therefore it is convergent. Next, for part 4, we are asked to make use of the answer in part 2 to find the expression for yet another summation sign. We shall now write down the summation sign. So, the solving method of this kind of question is relatively similar across the board. What we need to do is to make this expression look similar to the one in part 2. If they can be similar, means to say we can use the part 2 result. So we shall play around with this expression by factorizing the second term in the denominator. Then we shall rearrange this into the same format as that in part 2. So format wise, they are the same. Next, we can compare them. So we can see that we can make use of a simple substitution of n equals to n plus 1. Let's see what happens to the expression. So clearly, this substitution will transform the expression into that in part 2. This substitution will also change the limit, with the lower limit becoming 1 and the upper limit n minus 1. So since they are the same, so we can make use of the part 2 result. But in this case, since the upper limit is n minus 1, so from the part 2 expression, we shall sub n as n minus 1. And we can further simplify this to give us our final answer. So next, we shall move on to question number 2. Question number 2 falls under the topic of application of differentiation. Over here, we are required to maximize the volume of this model. So first of all, I'm going to draw the 2D model on my paper. So basically it consists of a cone and a cylinder. Height of the cone is given to be 5x, radius 12x. and the height of the cylinder is y. So since we want to maximize the volume, we need to write our cost function. In this case, our cost function will simply be the volume equation, and the total volume of this model is made up of the volume of the cone plus the volume of the cylinder. Volume of the cone is given as 1/3 pi r square h plus volume of cylinder pi r square h. We're going to sub in the respective values. R in this case 12x, h 5x for the cone, and r 12x for the cylinder, and h is y for the cylinder. So if we compare this volume expression to what is needed in the question, we realize that we have the y. So we have to eliminate the y using a substitution. So the substitution will come from our constraint equation. The constraint for this question is that the total cost of painting this model costs $100. So the total cost is made up of two parts, cost A and cost B. Cost A will be the cost of painting the curved area of the cone, and the price per centimeter square is $0.05. So cost A can be re-expressed as curved area of the cone times 0.05 plus cost B is made up of curved area of the cylinder plus the base area, and the cost of painting this is $0.02 per centimeter square. These two components will add up to our $100. So for the curved area of the cone, it's pi RL, where L is the slant height of the cone. Curved area of the cylinder, 2 pi RH, plus the base area, which is a circle, pi r square. So next we have to sub in the values that we have. So R is 12x. Then we need L. So to get L, go back to our model, we can see that L is here. So by using a simple Pythagoras theorem, we can solve for L. L in this case will be 13x. So we're going to take this value and sub into our equation. And we are going to fill in the respective variables for the cylinder. 12x, y, 12x again. So our objective here is to make y the subject so that we can substitute this into the cost function to remove the y. So we simplify this, and then we will make y the subject. So now we have equation 1, which is our cost function, and 2, which is from our constraint equation. The next step is to substitute the equations together. So basically, we're going to remove the y. So from here, we can simplify this to show what is required by the question. After we have done this, we need to differentiate v in terms of x. So this gives us this expression. So to obtain the maximum point, which is a stationary point, we have to set dv dx to be 0. And we can solve for our x, which is 1.04, and from our equation 2, y will be 40.9. And the final step is to verify that this is a maximum point. To do that, we'll use the second derivative check, since it is relatively easy to differentiate dv dx one more time. So we'll get this expression, and this will be always less than 0 since our x is positive. Therefore, since the second derivative is negative, this will be a case of maximum. So that's it for question 2. So we have come to our last question, question number 3. Question 3 is a vectors question, testing us on 3D geometry. So first, what I'm going to do is to redraw the rectangular 3D geometry on my piece of paper. So the base of this rectangle is labeled as O, A, B, and C on the far end. And the top will be E, F, G, and H. So it is given that the orthogonal axis IJK is planted at the origin. So let me label them. On top of that, we are given the length of OE is 2 units. So let me write it down. And 3 for OC, 4 for OA. So before we start the question, we can write down the vector OE, which is 002, since the magnitude is 2 units and is in the direction of K. We can perform the similar step to find out OC and OA. So we shall begin with part 1. Part 1, we are asked to find the equation of the plane ACE. So I'm going to redraw the plane again And to get the equation of the plane, we need two vectors and one point on the plane. So for the two vectors, I'll be using AE, which is AO plus OE. This will give us minus 402. And for the next vector, we'll use CE, which is CO plus OE. And this will give us 0 minus 32. Then we can compute the normal to the plane. So the normal to this plane can be computed by cross product. So we're going to cross AE with CE. This will give us 6, 8, 12. And since we only need the direction, we can factorize out the common factor. And this will leave us with 3, 4, 6. With the normal of P, we can proceed to find the plane equation. Using the scalar product equation, R dot n equals to A dot n. N will be 3, 4, 6. For the point, we shall use point A, 4, 0, 0. And the right hand side will give us 12. And we convert this into Cartesian form. That's it for part 1. So for part 2, we are asked to find the angle between plane P and plane OABC. So I'm not going to mess up my diagram. What I'm going to do is to draw the simplified scenario. So what we need is the angle between these two planes. So from our lecture, we know that the angle between two planes can be found using the angle between the two normals. Since the angle between the two normals is directly opposite of the angle between two planes. So to find out the angle between the two normals, the normal of P we have found to be 3, 4, 6. Next, we need the normal of OABC. So let's look at the diagram. So OABC is the base. Clearly, the vector K is perpendicular to OABC. So the normal of OABC is simply 0, 0, 1. So to find the angle between these two normals, we simply use our dot product formula. So resolving the dot product inside, you give us 6 over square root 61, and theta will be 39.8. Next, for part 3, we are given that there is a line L which is perpendicular to P and intersects the plane that contains BCGH. So again, I'm going to draw the 2D diagram, or a simplified 3D one. So this is the plane CBGH, and the line passes through origin and cuts this plane at point T. So we are left with a simplified scenario, as T is basically the intersection between the line and the plane. And from our lecture we learned to find this intersection. Basically we just need the equation of the line and the equation of the plane. So first we need to find out the equation of plane CBGH. Again, we'll use the scalar product formula R dot n A dot n. So the normal to CBGH, we shall refer back to our diagram. So for this CBGH, clearly the vector J is perpendicular to CBGH. So n in this case can be simply written as 0, 1, 0. For the point, we shall use C, which is 0, 3, 0. So this is our plane equation. So to get the line equation, we need the direction and a point. Since the line is perpendicular to plane P, the direction of the line is basically equals to the normal of plane P. Therefore, the line equation is 0, 0, 0 plus lambda 346. So that's it. We have the plane equation and the line equation. So to solve for the intersection, we basically equate them together. So once we equate them together, we will find ourselves being able to solve for lambda. So lambda in this case will be 3/4. And substituting this back into the line equation, we can get OT. The second part of this question requires us to deduce the perpendicular distance from T to P. So let me draw a 2D diagram to represent the scenario that we have. So we have the plane P, the origin, and the line. Point T is somewhere here. So what we need is actually the distance between T and P. So to get this, we can simply use the distance from T to the origin to subtract away the distance from plane P to the origin. So to get the distance from plane P to origin, we can deduce it from the scalar product form. From the textbook we learned, it's basically 12 divided by the modulus of 346. And next, for the distance from the T to origin, we basically take the modulus of OT. And this will give us 3/4 square root 61. Therefore now we can solve for our distance between T and P by subtracting one from the other. This will give us 135 over 244 square root of 61. That's it for part 3. Next, we move on to part 4. For part 4, we are given that there's a point Q which lies on the line that passes through C and T, such that the distance from P is twice that distance from T to P. Find possible values of Q. So we shall assume two values of Q. So this will be point C, or point T, and Q1. So since the distance from T to P and Q to P is twice of one another, we can draw this, and Q2 will be on the other side. By similar triangles, it can be clearly seen that we can write down this relationship. So therefore, we can write two times of CT is equals to CQ. And if Q is on the other side, we can write 2 times of CT is equals to negative of CQ. So using these two relationships, we can solve for our Q. So put in the values of C and T respectively on the right hand side. Now left hand side, it is our CO plus OQ1. So CO is 0 minus 3, 0 plus OQ1, which is the one that we want to solve. Right hand side simplifies to half 9018. So from here we can solve for our OQ1. So we shall do the same for the other side. CQ2 will be 2 times of negative 2 times of CO plus OT. So re-express CQ2 as CO plus OQ2. Plug in the values for CO and OT. And using the same method, we can solve our OQ2, which is half 9 minus 9, 6 minus 18. So this will be our 2Q values. Alright, that's it for my first online tutorial. Thank you for your kind attention.